Okay, this is the last video for our differentiation in-class practice for Calculus 1, so that's exciting. And I've got a couple more problems here that I'd like to do with you, and this one is h of x equals the natural log of x plus radical x squared minus 1. Well, the first thing I always do when I see natural log is to see if I can use any log rules to split that apart. And I see that there's addition inside the parentheses, so there's no way I can pull this apart. So I'm going to start doing the log derivative, which is 1 over u times u prime, the natural log derivative. Before I do that, I always kind of like to write my radicals like this, x squared minus 1 to the 1/2, so I know I can go back and use that when the time comes. So let's start doing the derivative. I'm going to do h prime of x, and I know the derivative of natural log, is 1 over u times u prime. So that's u, so I'm going to write 1 over u. So funny, my voice was long. Times u prime, and u prime is going to be the power rule, don't touch the baby, to the negative 1/2, times the derivative inside, which is going to be 2x. Okay, so when I look at just this piece of it right here, I'm very excited to say I can cancel those 2's out. They divide out to make 1. So I end up getting h prime of x to come out to be 1 over x plus radical x squared minus 1. And this is times, and I'm just going to rewrite it, 1. Oh, I forgot to do the derivative of x. Well, you know what? Let's do that again. So I hope some of you caught that. I looked right at this. So when I take the derivative of u, I forgot that x. So it's going to be 1 plus 1/2, don't touch the baby, to the negative 1/2 times 2x. I'm sorry about that. So this is going to be all together here. I've got ahead of myself. That happens. So now I look at it here and I said, oh, thank goodness I can cancel out those 2's. So now I have this 1 plus, and I'm just rewriting it. This x can go in the numerator. This right here can go in my denominator. And I'm going to write it as a radical. Why did I do that, do you ask? Well, one of the reasons why I did that is I want to simplify this. So our calculus is done after I fix my mistake. And so what I always try to do is see if I can do a common denominator over here to see if that would make this simplified all. So I'm going to leave at h prime of x, leave this first fraction alone. So I have 1 over x plus radical x squared minus 1 times, now if I do a common denominator here, this would be over x squared minus 1, then I would multiply this first one by this denominator, so that'd be radical x squared minus 1 plus x. So now I have a fraction times a fraction, and when I look at this, I guess I got ahead of myself, so excited. These two can cancel. So I love it when that happens. So these divide to make a 1. So I have h prime of x equals 1 over radical x squared minus 1, which is a nice way to finish this out. So I do apologize for my mistake. And what I did up here was I got so excited to take the derivative of u, I forgot you have to take the derivative of x, which is 1, and then to do the derivative of that. So that's number 12. Now the very last one in this packet, hooray, we've made it, is number 36 here, which I didn't write down the directions, but they wanted you to do this using logarithmic differentiation. So every time I do this with my students, they always say, well, how are you supposed to know? Don't worry, I'll tell you. Because you could actually do this and say, all right, I'm going to write this like this, x squared plus 1 over x squared minus 1 to the 1/4. And right here, you could actually start doing the power rule and then the quotient rule. So you're getting to the point where there's many, many ways to do your derivatives, many ways. But what I will do is tell you that I want you to use logarithmic differentiation. So I'm going to actually natural log both sides this in a minute, but I'm going to continue on because I am going to use logarithmic differentiation. And because this fraction is raised to the 1/4, I can do each the numerator and the denominator raised to the 1/4. So that now when I go to natural log both sides, so I'm going to bring it over here, I can now use my log rules to expand that, and then we can do the derivative from there. So I have the natural log of y equals the natural log of x squared plus 1 to the 1/4 over x squared minus 1 to the 1/4. And then I see there's division inside there, so I can expand it more. I haven't done the derivative yet, just so you know. I just natural logged it. And I'm going to expand it so I can bring the 1/4 down front, the natural log of x squared plus 1 minus 1/4 the natural log of x squared minus 1. So I hope that didn't confuse you. I could have written it as a natural log of this raised to the 4th minus the natural log of this raised to the 1/4 and then bring the 1/4 down. I just kind of did it all in one step. Okay, now, only now, so I'm going to change the color here, am I going to start to do the derivative. All I did was natural log it and then expand it using log rules. So now I have 1 over y dy dx is going to be, all right, 1/4, and I know this is my u, so it's going to be 1 over u times u prime. So I have 1 over 4, and then the derivative, I don't actually need to write the 1. The derivative of u is 2x, so I'm going to put that here, and this is going to be over x squared plus 1. So I did 1 over u times u prime in one step, which makes it cool, so now I can see it divides out, minus, ready? I have the same thing, 1 over 4, and then I know I'm going to put x squared minus 1 in the denominator and then multiply by the u prime and throw that on the top. And a lot of times you'll see the derivative of natural log is u prime over u. So now I end up with this. I have 1 over y dy dx equals x over 2 x squared plus 1 minus x over 2 x squared minus 1. So here's where I'm going to show you how the textbook did it, just because you have the answers for the textbook, but you kind of have a choice here. I actually did it a different way, but they came out the same. So I'm going to multiply both sides by y so that I can actually solve for dy dx. And then when I bring the y down, it's going to be that huge radical that was there. So I'm going to bring that huge radical here. So it's the 4th root of x squared plus 1 over x squared minus 1. And it's going to be times this. Okay? But what they, well, I'll just do it here because I don't want to confuse you. They actually, in the book, factored out a 1/2 because both of these are divided by 2. So what I'm going to do here is erase this. And I'm going to factor out the 1/2 and throw it right in the front because they looked at this and said, oh, I can say this is equal to 1/2. This is my y from above. And then here I have x over x squared plus 1 minus x over x squared minus 1. So I just wanted to show you that because they want us to do a common denominator here, and it makes it so much easier just because you don't have to worry about the 2. So I have dy over dx equals 1/2 the 4th root of x squared plus 1 over x squared minus 1. And then all we're going to do here is multiply this by the common denominator, which is x squared plus 1, x squared minus 1. And when I do the common denominator, you know, you've done this so much, you're going to multiply this x by this denominator. So I end up having x cubed minus x minus, and then I'm going to multiply this x by this denominator. So I have x cubed plus x. And then here we're just going to kind of simplify everything. So we're nearing the end here. I see these x cubes cancel out, so I have a negative 2x in the top. So I have dy dx equals 1/2 the 4th root of x squared plus 1 over x squared minus 1 times negative 2x over x squared plus 1 times x squared minus 1. All right, so I'm getting closer. I do notice that the 2's will cancel out now, so that makes it nice. That divides out to make a 1. And the only difference that the book did was they kind of multiplied these two together because it's a difference of 2 perfect squares, and they stuck the negative up front. So this is what you'll see they did. They have dy over dx because the 1/2 is gone. They have negative x, and then they multiplied the denominator as x to the 4th minus 1, and then they multiplied it by that big, beautiful radical, the 4th root of x squared plus 1 over x squared minus 1. And there's several ways to do this. In fact, when I did it the first time, I actually kept going. So I'm just going to stop there, and I hope this helps. Congratulations.